On construction sites around the world, one of the most common and most overlooked environmental violations is happening right now, at the concrete chute. This is Concrete Washout Done Right, a complete compliance guide for environmental professionals who need to get this correct.
Here is what we cover. We start with the real problem. What is actually happening on sites right now, and why it matters. Then we move through the consequences of getting it wrong, a 5-point site risk check you can apply today, and a step-by-step compliance setup guide. From there, containment system selection, the 6-stage wastewater treatment process, monitoring requirements and discharge limits, and finally, documentation, common mistakes, best practices, and an action plan you can implement this week. Everything a practicing environmental professional needs.
By the end of this training, you will be able to identify and assess concrete washout risks on any live construction site. You will be able to design a compliant washout containment area from scratch, any project, any scale. You will be able to apply the correct 6-stage treatment process for alkaline wastewater discharge, establish a complete monitoring and documentation framework that stands up to audit scrutiny, and defend your environmental controls in front of auditors from NEOM, Saudi Aramco, or any internationally benchmarked client. And when the auditor asks the 5 washout compliance questions, you will answer without hesitation.
Here is what happens on construction sites every single day. A concrete mixer finishes a pour. The driver needs to wash out the drum. There is no designated area, so the driver picks whatever is convenient. Behind the equipment yard, near a drainage channel, on bare ground. What comes out of that drum is not just dirty water. Fresh concrete washout is highly alkaline, typically between pH 11 and pH 13. That puts it in the same alkalinity range as household bleach. When that slurry contacts bare soil, it raises the local pH, destroys beneficial soil microorganisms. And if it reaches a stormwater drain or a natural waterway, it can be acutely toxic to aquatic life in relatively small volumes. No liner, no signage, nothing written down. And in most cases, no one on site was even briefed that this is an environmental risk. Does any of that sound familiar? Because this is exactly where most site environmental violations start.
When concrete washout is mismanaged, 3 areas take the hit. Regulatory. Your project receives a non-conformance report. Depending on severity, that NCR triggers a stop work order on all concrete operations until the issue is formally closed out. The violation goes into your environmental register, and on any internationally benchmarked project, that record follows your team into future tenders. Environmental. At pH 11 to 13, alkaline slurry is acutely toxic to aquatic ecosystems. It raises water pH beyond survivable range for fish and invertebrates, breaks down the clay particle bonds that give soil its structure, and causes visible vegetation burn wherever it contacts plant material. These effects are not quickly reversible. Commercially. One documented environmental audit failure changes how every future client assesses your team's risk profile. A single finding is manageable. A pattern is a procurement problem. These are not theoretical. They are real outcomes on real sites. Solutions. Let us do a 5-point site check. These are the exact questions an environmental auditor will ask, and you should be asking them right now. First, does your site have a designated concrete washout area, formally marked on the site layout plan and approved by your environmental site manager? Not just an informal spot, a formally documented location. Second, is the containment pit lined with HDPE geomembrane? And is that liner completely intact? Because a damaged liner is no liner at all. Third, is the washout area at least 50 meters from the nearest stormwater drain, waterway, or site boundary? That is the minimum separation required under IFC EHS guidelines. Fourth, do you have a calibrated pH test kit on site?
And is the monitoring log actually being filled in? Not a kit in a drawer, one that is in use. Fifth, are disposal records being completed and signed after every single washout event? Not weekly, after every event. Any no in that list means your site has an active compliance gap right now. The rest of this training closes every one of them.
Setting up a compliant concrete washout area is 5 steps, and you can have a fully compliant system operational within 1 working day. Step 1. Location. The area must be at least 50 meters from any stormwater drain, waterway, or site boundary. Choose a naturally level area, mark it on your site layout plan, and get formal ESM approval before excavation begins. Step 2. Excavation. Dig to 300 to 500 millimeters depth. Compact the base and sides firmly. Grade the floor toward a central low point where settled solids will collect. Step 3. The liner. Install HDPE geomembrane at minimum 0.75 millimeter thickness. Run the liner up all 4 walls to at least 300 millimeters above the maximum fill level. Overlap every seam 300 millimeters and seal all joints. Inspect the full liner surface before the pit goes into service. Step 4. Signage. Install bilingual signs, English and Arabic as a minimum on Gulf projects. The sign must read "concrete washout only," display the pit's maximum capacity in cubic meters, show the ESM's contact number, and prohibit any other waste type. Step 5. Access control. 1 defined entry and exit point. A wheel wash at the exit, so tires are clean before re-entering the site road network. That is a complete compliance system. Any project can implement this.
There are 4 concrete washout containment system types, and the right choice depends on your project scale, your duration of concrete operations, and the environmental sensitivity of your surrounding area. Portable washout bags are constructed from reinforced polyethylene fabric, deployed in minutes, no groundworks, no excavation. The right call for small projects, remote locations, or temporary satellite work areas. Limitation: capacity is limited to 0.5 to 2 cubic meters, meaning more frequent management on high-volume sites. HDPE-lined earthen pits are the standard specification for large construction projects with sustained concrete operations, essentially unlimited custom sizing, low material and labor cost, and straightforward decommissioning at project closeout. The requirement is space and early planning, not something you add after concrete operations have started. Precast concrete units are used in permanent or semi-permanent batch plant yards. Structurally robust, no liner maintenance, reusable across multiple projects. Higher initial cost, offset by longevity on multi-year programs. Double-wall containment tanks are specified for environmentally sensitive zones, adjacent to a wadi, within a groundwater protection area, or near protected habitat. Zero ground spill risk, even on full inner wall failure. Premium cost for zero-risk performance. Match your system to the site risk profile and project duration, not just whatever happens to be available nearby.
Once wastewater is collected in your lined containment pit, it moves through a structured 6-stage process before it can be legally discharged or reused. Stage 1. Collection. Direct all concrete washout water, drum washout, chute rinse water, truck exterior washdown, into the lined containment pit. No other waste streams enter this pit. Stage 2. Settling. Allow the collected wastewater to settle for a minimum of 48 hours. During this period, suspended calcium hydroxide and calcium silicate particles drop under gravity to form a solid sludge layer at the base. Atmospheric carbon dioxide also begins to react with dissolved calcium hydroxide, forming calcium carbonate and naturally reducing pH through carbonation. Do not disturb the water during settling. Stage 3. pH testing. This is the critical decision point. Using a calibrated digital pH meter, take a representative sample from mid-depth in the clear supernatant above the sludge. If the reading is above pH 9, proceed to stage 4. If the reading is pH 9 or below, proceed directly to stage 5. Stage 4. pH adjustment. Two methods are in common use. CO2 injection. Compressed carbon dioxide is bubbled through the water, dissolving to form carbonic acid and neutralizing the dissolved alkalinity efficiently and without introducing chemical contaminants. The alternative is weak acid dosing, typically dilute sulfuric or hydrochloric acid, effective but requiring trained chemical handlers and proper secondary containment. Stage 5. Retest and confirm. The IFC EHS guidelines set the permissible discharge range for construction phase wastewater at pH 6.0 to 9.0. Your water must fall within that range before any discharge is authorized. Below that range or above it, return to Stage 4 and repeat. Stage 6. Dispose or reuse. Confirmed compliant water can go to a permitted foul sewer connection or be reused on site for dust suppression on whole roads or as non-structural concrete mixing water. On-site reuse eliminates the disposal step and reduces your freshwater demand. Follow this process every time. No shortcuts, no exceptions.
Monitoring converts your physical containment system into a defensible compliance record. Without monitoring data, your washout area is infrastructure. With it, it becomes a documented environmental control that withstands audit scrutiny. 4 parameters. pH. Test daily during any active discharge period. Use a calibrated digital pH meter. Record the reading, the date, the time, and the name of the person who conducted the test. The permissible discharge range under IFC EHS guidelines is pH 6.0 to 9.0. Any reading outside that range means no discharge until the cause is investigated and resolved. TSS, Total Suspended Solids. Send a water sample to an accredited laboratory on a weekly basis during active washout operations. The IFC EHS limit is 50 milligrams per liter. Consistently elevated TSS results signal that your settling period is insufficient. Increase the minimum settling time. Volume. Measure and record the volume collected after every washout event using a calibrated dipstick or in-pit flow meter. Volume tracking tells you when the pit is approaching capacity and when sludge removal is needed. Visual condition. During every formal site inspection, assess the supernatant. Clear above the sludge? Any surface sheen indicating hydrocarbon contamination? Liner intact? Signs in place and legible? Record your findings with your signature. These 4 activities are the evidence trail that allows you to stand in front of an auditor and demonstrate, with dated, signed records, that your environmental control has been functioning throughout the project.
There are 4 records specific to concrete washout management that your environmental file must contain. An auditor will look for all 4. Missing any one of them is a finding in its own right. First, the concrete washout log, a field-level record completed by the operator after every washout event, without exception. It captures the date, the time, the approximate volume of wastewater generated, the disposal method used, and the operator's signature. This log lives at the washout area, not in the site office. Second, the pH monitoring record, a separate daily log capturing all pH test results taken during the discharge decision process. Each entry includes the date, time, pH reading, meter calibration reference, and any corrective action taken, including the post-treatment pH that confirmed compliance before discharge. Third, the waste transfer certificate, required every time wastewater is removed from site by a licensed disposal contractor. It identifies the waste type, the volume transferred, the disposal company's name and license number, the receiving facility, and signatures of both parties. Retain the original. Do not accept a copy only. Fourth, the Environmental Inspection Report, a monthly formal inspection of the entire washout system, liner condition, signage, setback compliance, sludge levels, and a review of all washout event logs for the preceding month, signed by the environmental site manager, filed as a controlled document in your EMS records. All 4 must be retained for a minimum of 3 years after project completion. That is ISO 14001 Clause 7.5, and it is reinforced explicitly in your project CESMP obligations.
5 mistakes that consistently appear in concrete washout audit findings, and the exact fix for each. Mistake 1. The washout area placed too close to a stormwater drain. The fix? Relocate to a minimum of 50 meters from any drain, waterway, or boundary. If immediate relocation is not feasible, install temporary impermeable bunding between the existing pit and the drain as an interim emergency measure, with a set deadline for permanent relocation. Mistake 2. The HDPE liner cracked, torn, or punctured, and the pit still in active use. A compromised liner is a failed containment system, regardless of how small the damage appears. The fix? Weekly liner inspections on a signed formal checklist. Any damage? The pit is immediately out of service until the liner section is fully repaired or replaced. Mistake 3. No signage, or signage in one language only. On any project with a multilingual workforce, single language signs are functionally invisible. The fix? Bilingual signs. Minimum English and Arabic, showing the pit is concrete washout only, the maximum capacity, and the ESMP contact number. Mistake 4. pH not tested before disposal. This is not just a documentation gap, it is a process failure. The fix? The discharge valve stays locked until a pH reading has been recorded and signed off in the monitoring log. If there is no valve, install one. Mistake 5. No disposal records, or records filled in retrospectively. The fix? The washout log is completed on the day of the event, by the operator, with a genuine signature. Every one of these is correctable within one working day. None of them should appear in an audit report more than once.
10 best practices from sites that consistently pass their environmental audits. 1. Size your containment pit to 150% of your daily washout volume. Always maintain 20% freeboard. 2. Install a lockout discharge valve, a physical barrier that prevents any discharge before a pH test is completed and authorized. 3. Put the washout area on the environmental management drawing at site setup, not as an afterthought when concrete operations have already started. 4. Brief every concrete truck driver on the washout location at the site gate, every single pour, not once at site induction and never again. 5. Designate one named person responsible for washout log completion each day, not everyone, which means no one. 6. Weekly HDPE liner inspections on a formal signed checklist with a replacement protocol that kicks in the moment damage is found. 7. Calibrate your pH meter weekly and record the calibration date in your monitoring log. An uncalibrated meter reading is not a defensible discharge authorization. 8. Photograph the washout area during every monthly inspection. Dated images filed in your EMS provide visual evidence of condition over time. 9. Keep the washout log at the containment area, not in the site office. The log is a field document. It should be where the work happens. 10. Begin decommissioning planning at 75% project completion. Liner disposal, sludge drying and classified waste removal, pit backfill and reinstatement, these take time and planning, not something to address in the final week.
3 things to take from this training. First, concrete washout at pH 11 to 13 is a live environmental hazard. It is not a paperwork obligation. It causes real, measurable, and in some cases irreversible damage to soil, groundwater, and waterways. And it generates regulatory consequences that are recorded against your project and your professional history. Second, a fully compliant system can be set up in under 1 working day. The physical setup is not what prevents compliance. Awareness is. This training addresses that directly. Third, the monitoring and documentation trail is what actually protects you under audit. An auditor cannot observe your site's history. They can only evaluate what has been recorded. A site with complete, accurate, dated documentation consistently outperforms a site with good infrastructure and no records to support it. Your action plan for this week. Walk your site today. Physically locate every point where concrete washout is currently happening, authorized or not. Apply the 5-point compliance check to each location. For every no, assign a corrective action, a responsible person, and a deadline today. Then open your washout log. If it does not exist, start it today. If it has gaps, Bring it current with what is known and implement a daily review from this point forward. Do those 3 things this week.
That is everything you need to manage concrete washout to an internationally recognized environmental standard and to defend your controls under audit. Share this training with your site team. 20 minutes that removes significant environmental and regulatory risk from your project. Subscribe to EnviroVerge for more field-ready environmental training, and we will see you in the next video.